In this video, we are going to introduce the concept of the dot product. The dot product is a method for multiplying two vectors together. Now, in multiplying two vectors together, what we're actually measuring is how in the same direction are the vectors. Now, given that we are dealing with simply the directions of vectors, we tend not to worry about the magnitude of the vectors. Now, if they are in the same direction, then what tends to happen is that the dot product is positive. If they tend to point in opposite directions, then the dot product is negative. And somewhere between opposite directions and the same direction, we have a sweet spot right in the middle. That sweet spot right in the middle is when they are perpendicular to each other. In that case, the dot product is measured to be exactly halfway between positive and negative, which would be 0. So in this case, we might say that the vectors are perpendicular, or, fun word for you, the vectors are also referred to as orthogonal. Orthogonal is the generalized term for things that are perpendicular to each other. Now, as far as actually calculating a dot product is concerned, is if you have two vectors, so if vector A is the vector A1, A2, and the vector B is B1, B2, then the notation that we use for a dot product is quite literally a dot in between the two vectors. Multiply the corresponding components together. A1 gets multiplied by B1, and A2 gets multiplied by B2. Once you do that, you add the result together, and then interpret as is above. Now for a couple examples of this. Let's do A is equal to the vector 2, 3, and B is equal to the vector 3, 1. Now, based off of the fact that both of these vectors are quadrant 1 vectors, my prediction is that we are going to get a positive value for the dot product. That is to say, the angle in between them is going to be acute. So the dot product of these two vectors, A dot B, is equal to 2 times 3 plus this 3 times this 1. And indeed, the result that we get is positive. Now for another example, if we say that A is the vector, let's do 5, 4, and B is the vector, let's do -2, -3. So vector A points into the first quadrant, and vector B points into the third quadrant. My guess is, because they're pointed in opposite directions, that we're going to get something that is negative. So A dot B, that's going to be equal to 5 times -2 and 4 times -3. And indeed, it does appear as though the result that we're going to get is going to be quite negative. That lets me know that the angle between them is obtuse. That is, bigger than a 90-degree angle. Now, of course, there is a sweet spot right in between them, where if we say that A is the vector 3, 1, and B is the vector 2, -6. Vector A, then, points into the first quadrant, like so, and vector B points into the second quadrant, like so. If I take the dot product of these two vectors, that would be 3 times 2 plus 1 times -6, giving me 6 minus 6, which is 0. I can tell because the dot product is equal to 0 that these two vectors are orthogonal. And that's the end of the semester.